Sure. Welcome to the practice set on multiplying and dividing rational expressions. Please like and subscribe. If you find this video helpful, drop a comment or question to engage, and check out the many other videos and playlists that are on the channel. Without further ado, let's go dive into the practice set. So pause the video to work these problems on your own and then come back to check your work. All right, so we're going to get into this. I kept this practice set pretty brief. It's only 4 problems, and that's because each of these 4 problems involves like multiple factorings. And so in an earlier problem set, this could be something like, 10 to 15 problems worth of like factoring work. So we don't want to like be overwhelming with that, but we do want to get enough practice in so that we know how to navigate expressions like this. Now, this is one of the times, I don't do this all the time, where I'm recording the practice set video before I've recorded the lesson. That is the order that I have to upload them. So sometimes I do it in this order. Usually I don't. Hopefully everything goes smoothly with these practice problems. So we're going to start off with 2 multiplication problems. And if you recall from the lesson, hopefully you have watched the lesson first because it will be recorded. But we know we want to factor everything, and then we're going to look for those common factors. So just like with simplifying a single rational expression where you would factor everything, now we've got the operator going on in there. And when I do problems like this, I try to figure out the easiest possible way for me to navigate this. And I'm going to try to model that in the first 3 problems. And then the 4th problem, it doesn't work out quite as well. And a good reminder that, you have strategies to help, but they don't always work perfectly. So as I'm looking at that, I kind of see this as, let's see if we can straighten that out. It's a bit much. This part right here, I think I'm going to start with that. And what I see there is a common factor of 2. And so I see 2x plus 4. I see a GCF of 2. So I'm going to go ahead and pull that 2 out. And I would be left with x plus 2. And then, of course, if I multiply that through, 2 times x is 2x and 2 times 2 is 4. So you can see where that's coming from. Now what I'm going to do is try to leverage this a little bit. So I've got a 2. I've got an x plus 2, and what I'm expecting to have happen is things to cancel out. Like I'm expecting to see maybe a 2, maybe an x plus 2 in one of the other parts. Specifically, I would expect to see it in the denominator. So what I'm going to do is look at my denominator and see, is there a spot where I could factor out a 2 or factor out an x plus 2? Do I see anything that looks promising? And that looks more promising over here. Now, I don't see a common factor of 2. What I see there is a common factor of 4. So I'm going to go ahead and grab the common factor of 4. And if I factor the 4 out, I will get x squared minus 4. And I can double check that as well. 4 times x squared is 4x squared, and 4 times 4 is 16. So I know I've done that correctly. And what I know here is that this is the difference of squares. So x squared minus 4 factors into x plus 2, x minus 2. Now, here's where how you're showing your work, you want to be careful about it. In my own personal work here, I would probably leave it like that. However, if I were doing this on a test for like it to be evaluated, I would probably do a fresh step where I did the x plus 2, x minus 2. And then I would bring this down as well with it. Just because of like when you're being evaluated, you don't want to assume that somebody else can figure out what you were doing or what you were writing there. Okay, so let's look at the other 2 pieces. Now, these look about equally difficult to factor. This one's got slightly smaller numbers, but it has more negatives. This one has a little bit bigger number, but it's got the positive. I think I'm more of a fan of the positive there, so I'm going to go with that one and see if we can't get that factored. So coming over here, I've got x squared, and I have a positive 3, and I'm going to do A times C, so 1 times 3 is 3, and I'm looking for two factors of 3 that add up to -4, and that would be -1 and -3. Okay, and our double check on that. -1 plus -3 does give me -4. -1 times -3 does give me +3. And so this would be -1x and -3x. And so this ends up being x minus 1 and x minus 3. And I'll copy that down here. I'm aware that that's a bit of an extra step there. Okay, and now we've got to cover this last factoring here, and we're hoping for some of these factors like an x minus 1 or an x minus 3. That's like what we're hoping to see. So let's go ahead and do that scratch work. So this time we have x squared and we have a -3. So we're going to do 1 times -3 to get -3. And we're looking for two factors of -3 that this time add up to -2. So because they're factors of -3, this time one of them will be negative. So we're going to have the 1 and the 3 again, but this time the 3 will be negative and the 1 will be positive. So we end up with a little bit something different there. So we'll have 1x and -3x. So we have x and x. Now this is a positive 1. This is a -3. So x plus 1, x minus 3. And then what I'm going to do here is what we call cross canceling. So what we're going to do when we multiply the fractions is we're going to multiply like all of this garbage together. So all of this is going to end up in the same numerator. All of this ends up in the same denominator, and then we would cancel. But that seems like a lot of extra writing, and I feel like I've already done enough extra writing in this. So let's go ahead and find our common factors. So I have an x minus 3 and x minus 3. I have an x plus 2 and an x plus 2. And I do have something I can cancel out here with the 2. 2 in the numerator and 4 in the denominator would simplify to 1/2. So that cancels to a 1 and that cancels to a 2. And I don't think anything else cancels. So we are left with x minus 1 in the numerator and then 2 times x minus 2, x plus 1 in the denominator. And that matches what I got before when I wrote the problem. So yay for successfully doing that. And it took me about 6.5 minutes to do this one problem. So you can see why we want to keep the practice set fairly short. And I'm just now realizing like I wrote the factors in the one below. So if I were doing it for a test, I would outline the work like so with my scratch work off to the side. Okay. When you're doing it on your own, you might not be as particular. Okay, so for this one, we kind of want to approach this the same way. I see an x plus 5 there, and what I would like to have happen is have an x plus 5 appear in the numerator. And if that's going to happen, it would happen right here. I would have that x plus 5. So what I'm going to show you in this one is a trick of like, it's kind of being lazy. We're going to try to backdoor our way into the factor. Okay, so what I think will happen, and I showed this to my own students as well. I got the x plus 5. I think like I would like to see an x plus 5 in the numerator. Now I can't get a 5 out of that. Okay, the factors of 18 are like 2, 9, 3, 6, 1, 18, like not a 5. But my factors of 20 would include a 5 times 4. And so that's what I think is promising. So off to the side here, here's what I'm going to do. I'm going to start to factor that numerator. I'm going to put the x squared and the -20. And what I'm going to do is assume that one of the factors is x plus 5. Now, do I know for 100% certain that one of the factors is x plus 5? No, I do not. I do not know that for 100% certain, but I suspect it, just knowing the kind of problem it is. And what I'm going to do is see if I can make this work. So x times x would give me the x squared. 5 times x would give me 5x there. 5 times what would give me -20? That would be -4, and x times -4 is -4x. And then what I need to do is double check and make sure this actually worked. So x squared minus 20, 5x minus 4x is 1x, which is what I have over here. So in that case, it paid off. So my factors would be x plus 5, and then the other factor is x minus 4. Right here, this is another GCF factoring. So 3x and 18 have a common factor of 3. So I'm going to go ahead and pull that out, leaving me with x plus 6. And once again, I'm going to play a little bit of a game here. If I have an x plus 6 in the numerator, I think there might be an x plus 6 in that denominator. And what I'm going to try to do is backdoor my way into that factor. Okay, if I don't like factoring very much. So I have x squared and negative 24. And what I think the factor is I think it is x plus 6. Okay, it's my suspicion. So let's see if we can get it to work. X times x gives me x squared. This would be 6x. 6 times negative 4 gives me negative 24. Negative 4 times x is negative 4x. And then double checking, x squared, 6x minus 4x is 2x. So that is what I wanted. So we have x plus 6 and another x minus 4. So that, like, I feel pretty good about. Now let's do that cross-canceling step. So let's go find our common factors. I have an x plus 5, going to cancel with an x plus 5. If you can hear that in the background, that is my cat who wandered in and decided to make a lot of noise on her cat tree. X plus 6 and x plus 6 and x minus 4 and x minus 4. And I am left with a lone 3. So that entire problem, that entire messy problem simplified to just a 3. The end. That was a little bit faster, so that was a little bit less than 4 minutes. As you do these, you do get faster at them, and I am trying to point out some things that I would do looking at them to kind of speed up the kind of problem that this is. All right, this is a division problem. So the very first thing we want to do in a division problem is we'd like to rewrite it as multiplication. So that'll be 10x squared plus 7x plus 1 all over 2x squared plus 3x minus 2, and that will be multiplication by the reciprocal. So x squared minus x minus 6, and 5x squared minus 14x minus 15. So a couple things I'm noticing about this. One is this looks like a good place to start. That looks like the easiest. The rest of them all have leading coefficients, which is not friendly, so sorry about that. But I also notice this, that I have the 10x squared and I have the 5x squared, and I see some shared factors there. So I'm kind of expecting one of the factors to dump out of that is going to start with a 5x. And I think that's how the 10x is going to break up. And I also noticed this, 10 can break up into 5 times 2, and 5 plus 2 gives you the 7. So I see some combinations of numbers here that make me optimistic that this is not going to be horrible, but we'll see. All right, so let's set up our fractions, and then we just have to plow our way through this factoring. So I'm going to start with what I think is the easiest factoring one, and that's the upper right. So that'll be 1 times negative 6 is negative 6, and I'm looking for two factors of negative 6 that add up to a negative 1. My factors of 6 are 1 times 6 and 2 times 3. Well, to get the 1, I'm going to need the 2 and the 3. They need to add up to a negative 1, so I'll have a positive 2 and a negative 3, because 2 plus negative 3 is negative 1. So that'll be 2x and negative 3x. X times x gives me x squared. That's a 2. That's a negative 3. So I get my first set of factors as x plus 2 and x minus 3. Now, looking at this, I am not sure that this is going to work, but I would like to get an x plus 2 or an x minus 3 in the denominator. I think if I'm going to get an x plus 2, it's going to come over here. It's going to come from this, because this does not, the 5 and the 15 do not have anything that'll give me a 2. Now, I could get an x minus 3. out of this? Possibly. So that's kind of determining where I'm going to go next. Let's go ahead and go here. I'm going to avoid that leading coefficient of 5 for the moment. So let's come over here. And we're going to have 2x squared and -2. Now we're going to do 2 times -2 to get -4. And I want two factors of -4 that add up to +3. My factor pair possibilities are 1 and 4 and 2 and 2. If I want to get a 3, it's got to come that way, and the 1 would have to be negative. So this would be -1x and 4x. Now I really do need to do GCF factoring here. So the greatest common factor between 2x squared and -1x is an x. X times 2x gives me 2x squared. X times -1 gives me -1x. 2x times 2 gives me 4x. And 2 times -1 does give me -2. So I feel pretty good about that. And so we have 2x minus 1, and there's my x plus 2. So I know that those x plus 2's are going to cancel out. Now, let's see what we can do about this. I am not keen on factoring that for a couple of reasons. One of which is if I use the area model to factor that, I'm going to start by doing 5 times -15. And like right off the bat, I'm thinking, I don't think I want to do that. That's going to give me -75. And -75 is going to have a lot of factors in it. And I'm just kind of dealing with numbers that are big enough that I would like to avoid it. But what I think might be the case is I think one of those factors might be an x minus 3. So I'm going to take a bit of a gamble and see if I can save myself some time. And I am going to assume that one of the factors is x minus 3, and we're going to kind of cross our fingers and see if this is actually going to work for us. So looking at this space on the outside of the 5x squared, x times 5x would give me the 5x squared. 5x times -3 is -15x. -3 times +5 would give me the -15, and x times, nope, that did not work. But it should have, what did I do? Okay, I can leave the video recording, or I can pause it and try to work out what I did. I'm gonna pause it, and then I'm gonna work out what I did, and I'll be right back. Hang on. Okay, I found it. It's a copy mistake in my scratch work in my notebook. So I did not make any mistake here. Like there's no mistake happening here. I copied what should have been a 3 over as a 15. So what that means here is that this, so what was this? This was a 5 and this was a 5x. That does not add up. So I can try to get this factored, but I have a suspicion that it's not factorable, which means that I should probably put a disclaimer on this problem set somehow. You know what? I will work that out. So this ends up being like the -75. So like all I can do right now is like try to figure out, is there anything that would come out to a 14, and there isn't. Like none of these will give me a 14. So what that means is that this is going to have a whole other, like that is not factorable. All right, so let's look up here and see what we can do up here. So we're gonna just keep plowing ahead. All right, so 10x squared and a 1, and we're gonna do 1 times 10 is 10, and I need two factors of 10 that add up to 7. I actually already mentioned that's gonna be a 2 and a 5. So this is 2x, this is 5x. Greatest common factor between 10x squared and 2x is 2x. Okay, so that's got to be a 2x. This is then a 5x. That's a 1. That's a 1. And so this factors into 2x plus 1 and 5x plus 1, which, had I copied the problem right, would have canceled out with this, but I didn't copy the problem right. So we just have to cancel out what we can cancel, which ends up not being very much. I think it's only the x plus 2's that are going to end up canceling. So that's super ugly. So when it comes to leaving your answer, I would leave the answer like this. Okay. I would not bother multiplying any of that back through because it's going to be hideous and it's not going to take you anywhere that's beneficial. So I would leave it like that. And my apologies. So in a perfect world, if you would like to leave me a comment and say, hey, you need to redo this video because you copied a number wrong, then I can put this on my list when I'm done with all of my videos for like rationals, like to go back and re-upload a better version of this one. But like, feel free to do that. And yeah. Okay. And then let's take a look at this last one. I hope the last one comes out okay. All right. So again, first thing we're going to do is recopy this as a multiplication problem. Actually, I'm going to do 2 steps at once because as I am looking at that, because I don't want to copy like tons of extra lines, I see a common factor of 3. So 3x squared plus 6x plus 3 and 6x squared and 6. I see a common factor of 3. I see a common factor of 6. So as I am copying this down, I'm going to go ahead and pull out that 3. And down here, I'm going to pull out the 6. Okay, so basically I just undistributed that. And then I'm going to do this, rewrite this as multiplication. So I basically did 2 steps at once there, just recognizing, hey, I've got a common factor here. All right, so now we need to begin somewhere. Let's see where we want to begin. Well, we've got the x minus 1. And right here, I see the difference of squares. So x squared minus 1 is going to factor into x plus 1, x minus 1. So I know I'm going to have my x minus 1's canceled. In my numerator, I have a 3, and then I need to go ahead and factor that. So we have 1 times 1 is 1, and I need 2 factors of 1 that add up to 2. That's boring. 1 and 1, so 1x and 1x. X squared, 1 and 1, so this is going to factor into x plus 1, x plus 1. And then getting my 1 on the lower right there, we have x squared minus 12. So 1 times negative 12 is negative 12. And then my factor pairs for negative 12 are those. And I'm looking for something that adds up to a 1. So that's going to be negative 3 and positive 4. X times x gives me x squared. That'll be minus 3 plus 4. Check the 12. Everything looks good. X minus 3, x plus 4. And then let's go find the stuff that cancels. So I have the 3 over 6, which will simplify to 1/2. I've got one of these x plus 1's will cancel. I've got an x minus 1 that cancels, and that looks like it's about it. So I am left with x plus 1 in the numerator. Now I have a 2 in the denominator. I have an x minus 3, and I have an x plus 4. Okay, so that one was okay. So the third one had a typo in it. I will put a disclaimer somewhere. Maybe in the video lesson, I'll put the disclaimer since I haven't recorded that yet. We'll call it a day. Okay, so as always, don't forget to like and subscribe if you found this video helpful or potentially frustrating. Ask a question or drop a thank you in the comments, or don't roast me too bad for having a typo in it. I kind of like to think in the age of AI, that is your proof that I am not in AI. I know I don't put my face in the videos because half the time when I record these, I'm like, I've come back from a run and it's not pretty. But yeah, you're like, it could be one of those AI videos with clearly not an AI video. So, and check out the many other videos and playlists that are on the channel. The algorithm thinks you might like this one. I got an arrow pointing there. It's pointing to one side somewhere. There's a video. Go ahead and check it out and let me know what you think. And I hope to see you in a future video.